even though the EFIS systems are extremely reliable, it's required by both Boeing and the certifying authorities that we have basic backup instruments in the event that we have a failure of these EFIS systems in flight. So we are required to have standby instruments to give us all the information contained on that ADI from an alternative source. So fitted to the aircraft, as we pointed out earlier, we have a standby artificial horizon. We also have other standby instruments to fit along with that. We have a standby airspeed indicator and a standby altimeter. So that in the event that we lost completely the ADIs on both sides of the aircraft, because there's an identical system on the first officer's side of the aircraft, we've still got a basic set of flight instruments that we can use to fly the aircraft. So if we come back to the ADI just for a minute and look again at our flight mode enunciators on the bottom here, we've got 4 indications here at the moment. The first one is showing speed AT, which is speed auto throttle. So it's showing us that the speed of the aircraft at the moment is being controlled by the auto throttle system. The auto throttle system is being driven by the flight management system at the moment. We're also showing under that we have VNAV path, so it's showing us that the vertical profile of the aircraft is also being controlled by the flight management system. On the right hand side here we have a command indication which is showing us that we have an autopilot engaged in the command mode, so the autopilot is actually controlling the aircraft at the moment. Under that it is showing us LNAV, which is also showing us that the flight management system has control of the horizontal navigation of the aircraft. We'll now move on to the HSI, which is displayed directly below the ADI. The commonest form of display that would be used during normal operations of the Boeing 757 is a map display, which is driven directly from the FMCs. The map display, as you can see on the screen here, is showing the aircraft basic position. The white triangle represents the aircraft. The apex of the triangle is where we are at this time. The magenta line leading away from the aircraft is showing the route that is programmed into the FMC and that is being flown at this time by the autopilot. Most of you would recognize the more traditional display that we would have here. And if I select it now over to our basic VOR display, I think you'll recognize the display we have. So if we put it into our basic VOR display, we can see the basic representation of a compass, and our VOR information is being displayed on this beam bar in the center. We show a number of bits of information around on the screen. We show our distance to run to the VOR. We show the aircraft heading, and down in the bottom corner here we show what type of information we're displaying. So we're displaying VOR information on the left hand side and our wind direction and speed. So we're showing a wind direction of 101 degrees at 10 knots at the moment. We can also display ILS information in the same basic form. So I'll just select it across to ILS information now. And we see in ILS that we have a very similar display, a full compass around a beam bar in the center. And we also, because it's an ILS, we're displaying now glide slope information down the right hand side of the screen. Once again, we're also displaying heading across the top, and we may well be displaying a DME distance when we're closer to the ground, close to an ILS station. It's also showing us down here that we are displaying ILS information. We can then move on to another type of display. These full rose displays would very rarely be used on the aircraft. We've now moved on to the more modern presentations of map or expanded scale. So we'll just have a look at the expanded scale form of VOR and ILS display. First of all, if we go to the expanded mode of the VOR, we're now showing a very much compressed form of the compass. So we're showing something like a 60 to 70 degree compass arc. Still showing our same VOR beam bar in the center, and we're also showing that it's VOR information, wind information, distance from the station. Again, we can display a similar type of display for an ILS, and I'll just select that through now. And again, we can see on here a similar presentation of an expanded arc compass system showing roughly 70 degrees of arc, wind that we are displaying ILS information, and our glide slope information is also present because it's an ILS display. The modern presentation and the way in which the aircraft is generally flown, because we have the information available, is it would normally be flown in map mode. The modern EFIS system is a great benefit to pilots. I personally have been using EFIS systems now for the last 10 years, and they display so much information compared to the old mechanical instruments that they keep pilots far better spatially aware of where they are and what the aircraft is actually trying to do at any particular point in time. So most pilots have changed across to the EFIS displays and would be extremely reluctant to go back to conventional electromechanical instruments. The main display that is used on the EFIS instrument would be the map display. This would be the normal mode of operation in cruise flight. It displays a number of pieces of information, far more than we can display on a basic VOR or ILS presentation. We have a number of pieces of information on here. First of all, I'll turn off our airfield indications here so that we can show the screen in a slightly less cluttered form. So first of all, I'll turn off the circles which represent the various airfields along the route. We can change the presentation as we go along. We can look at different ranges on the instrument. So at the moment, we're looking at a full-scale range of about 320 miles. So we can see there we're showing 160 miles to our half-scale deflection. And I can choose what presentation I would like to show. So I can decrease the range to show more detail on the map. So I can change this on to a 160 mile full-scale range, which shows us 80 miles to the half-scale point. I can change it all the way down onto a 10-mile range if we were approaching a waypoint. So I can change the full range from 10 miles out to 320 miles. And you choose the range you're using depending on the number of waypoints that you're showing at the time. The other pieces of information we have displayed around the screen, we still keep our expanded scale compass showing roughly 70 degrees. Other pieces of information that we have displayed, at the top we have our heading, our actual magnetic heading. The little magenta rectangle under that is the heading that we have set on our heading bug on the mode control panel. In the top left-hand corner, we're showing the distance to our next waypoint, which in this case is Linz. So we can see from the scale here that it is in excess of 80 miles, and we're actually 99.7 miles from Linz. It is also showing us our time that we're expecting to pass overhead Linz. So in the top right-hand corner, we're showing our ETA there in Zulu time, and that is tied in with the captain's clock. So we can display a number of additional items on the screen, depending on selections that I make on the control panel for the HSI. I can display, for instance, airfields, which can be displayed on top by selecting the airports button on the control panel. So I'm now showing a number of airports around the aircraft. These would all be airfields that are suitable for an aircraft the size of a Boeing 757. So as we progress along the route, Dave will be picking up weather reports for these various airfields around us so that we know at any time which airfields are available should a diversion become necessary. One additional display we can also superimpose on our map display is a picture of weather around the aircraft. So we have a weather radar which I can switch on now to show you the display that we're going to get. Our weather radar display at the moment, if we look out the window, in fact, we can see we're just coming up to a nice view of the Alps down below us. There's very little weather that's going to show on our weather radar at the moment because there's very little cloud around. To give you an impression of what sort of things we'd see on the weather radar, we can also just tip the dish of the weather radar in the nose down slightly, and it will actually carry out a ground mapping function. So if I just tip the dish down slightly now, we'll see on the screen here that we're actually picking up ground returns from the Alps at the moment, and it's almost contoured in terms of yellow being the lowest ground up to red being the highest ground. If we were actually flying towards weather which we'd need to take notice of in the aeroplane, it would also contour the weather so that the red would be the worst of the weather, down to the green, which is the mildest form of weather. So we'd be using the weather radar to avoid the worst of the weather along the route. We'll now move on to the ICAS system, as displayed in the centre here. ICAS standing for Engine Indication and Crew Alerting System. If we deal with the engine indications first of all, we have displayed on both screens here a representation of the old traditional electromechanical instruments as fitted to older aircraft. So just running down the screen from the top to the bottom. First of all, the top indication here is engine pressure ratio. It's a measure of the amount of power that the aircraft is actually developing, or the engine is developing at the moment. Below it, we have our N1, which is one of the three spools in our RB211 535 E4 engines. So the RB211 engine is a triple spool engine, and we have indications on the screen here of N1, which is the main fan at the front of the engine, N2, which is the second stage inside the engine, and N3, which is the hottest section of the engine. So we've got three completely independent spools spinning at different speeds inside the engine. Also displayed on here, we've got exhaust gas temperature, which is showing us the temperature at a particular point within the engine. We move now from the EGT down to the fuel flow. At the bottom here you can see it's indicating 1.6. That's 1.6 tons of fuel per engine per hour. The 757 is fairly typical of modern aeroplanes now. It's extremely fuel efficient, and it burns roughly 3.5 tons of fuel per hour in normal cruise flight. There would be an additional fuel flow in the climb when the engines are running at high power, but that is normally well compensated for in the descent, where we basically have the engines at idle thrust for the descent. So overall, you can plan the trip on roughly 3.5 tons per hour. Also displayed on the bottom screen, we have some additional engine parameters. Starting at the top, we have oil pressures. They're displayed both in an analog form by the small pointers and in a digital form in the boxes. We have oil pressure at the top with oil temperatures underneath, oil quantities below that, with 20 quarts being the normal full quantity on the engine. Below that we have an indication of vibration levels on the engine, and it will indicate the highest vibration on any of the three spools within the engine. In common, all these parameters on the screens generally have red line limits and yellow or amber lines displayed. If any of these parameters should be exceeded, then the colours of these displays will change, alerting us that there is a problem on a particular indication, and we can then investigate that further. Also on the top screen here, two additional bits of information. The first one is we're showing here on the top TAT, or total air temperature, which is indicating minus 34 degrees centigrade. The actual outside air temperature at the moment, outside the aircraft, as indicated here on the FMC, is minus 61 degrees. The difference between the two temperatures is due to the kinetic heating as the aircraft passes through the air. So we're getting something like a 25 degree temperature rise on the skin of the aircraft due to our speed through the air. If we look once again at the EPA indications on the top set of gauges here,